In this video, we'll look at solving quadratics of any form. There's a whole bunch of different forms we're going to solve. The first one is x squared plus x minus 12. You know, you could use quadratic formula, but that's going to be a majorly long route. Instead, notice that it factors, or at least try factoring first. There's no common factor that goes into x squared, x, and negative 12. They have no numbers or letters in common. So I'm going to try what multiplies to negative 12 and adds to 1. The problem is, once people learn quadratic formula, they forget. It's much faster if you can factor. Try watching the video on BergMAN technique if you're not sure what I'm doing here. What multiplies to negative 12 and adds to 1? The numbers are 4 and negative 3. So I get x plus 4 times x minus 3 equals 0. I factored, but I'm not done yet. I still need to solve, so separate it into two pieces. Either x plus 4 equals 0, or x minus 3 equals 0. And now solve each piece. Subtract 4 both sides, so one solution is x equals negative 4. And the other solution, add 3 both sides, and x equals 3. That was way faster than quadratic formula. Done. Question 2. If you notice here, 2x plus 2 squared minus 5 equals 0, that's like vertex form. It is in vertex form. You could solve it by expanding it, getting it to standard form, and then factoring. That's a lot of work. Instead, I'm going to rearrange. Let's watch. I'm going to add 5 both sides, and I get 2x plus 2 squared, and then plus 5 minus 5 cancel, and I get 0 plus 5, so I just get a 5 on the right hand side here. And now I want to undo what's happening, get that x by itself, so get rid of this times 2. I divide both sides by 2, and I get x plus 2 squared equals, what's 5 split in half? You can do that with a calculator, but you could probably do it without a calculator. You have $5, split it in half, that's 250, or 2.5. Okay. Slow down here. What's the opposite of square? It's not quite a square root. The opposite of squaring something, we want to get rid of a square, is almost a square root, but a special kind of square root. It's a plus or minus square root. It can be either the positive version or the negative version of what multiplies to this number. So let's take the plus or minus square root of both sides. That cancels out the square effectively, giving x plus 2 equals plus or minus the square root of 2.5. One last thing to get x by itself. X is being added by 2. I'm going to subtract 2 both sides. And so I'm left with x equals plus or minus the square root of 2.5, take away 2. Now I've got x, but I still have two possibilities. I'm going to separate it into two pieces. Either x equals the positive plus square root of 2.5, take away 2, or x equals the negative square root of 2.5, take away 2. Notice only the plus or minus applies to the front of the square root. This take away 2 is take away 2 both times. And now I'm going to solve using a calculator, so I'm going to put a rounding dot, as I'm pretty sure there's going to be rounding. What's the square root of 2.5? Take away 2, and I get, let's round to 2 decimals, so 0.418. I'm going to round to 2 decimals, so the 8 means go up on this second decimal place, so that's negative 0.42. That's one of my answers. And it's not a word problem, so negatives are totally fine. Now I'm going to do negative the square root of 2.5, take away 2. And I get x equals approximately, I'm going to round to 2 decimal places, so the 1 means stay at the 8. So I get negative 3.58. And that's my other answer. So solve that one. So you don't always need quadratic formula, but sometimes you do. Here's m squared plus 10m minus 9 equals 0. What multiplies to negative 9? And adds to 10? Nothing. You could try like 1 and 9, but that's negative. Okay, so negative 9. It's not going to work. we got to pull out quadratic formula. You don't have to write this down. Sometimes I like to, so I don't mess it up. The a is the number in front here, a 1. The b is the number in front of the x, or in this case the m term, that's 10. And the c is negative 9. So quadratic formula, I'm solving for m. That's negative b plus or minus the square root of b squared minus 4ac all over 2a. Sub in. Negative b, that's negative 10 plus or minus the square root of b squared, that's 10 squared, minus 4 times 1 times negative 9, all over 2 times a. You won't believe how many times people forget this bottom part. 2 times 1. Okay, so m is negative 10 plus or minus the square root of, you can use your calculator, you might be able to do this in your head. 10 squared, that's just 100. So I get 100, and then minus 4 times 1 times a minus, that's a plus. So this is going to be a positive. 4 times 1 times 9 is 36. So I can do this all in my head. It's going to be 100, and then plus 36, easy to do in your head. 136, all divided by 2. At this point, I separate into two pieces. Either the m is negative 10 plus the square root of 136. Make sure those roots and those fractions cover everything. Divide by 2. Or, let's put a line here, m is negative 10 minus the square root of 136 all over 2. And I'm going to round almost certainly here because square root of 136 is going to be a big decimal. Negative 10 plus the square root of 136 equals, I always would hit equals there, so your calculator divides everything by 2. Let's round to 2 decimal places, so you get 0.83. The 0 means round down or stay at 0.83. I'm going to have to round here too. Negative 10 minus the square root of 136 equals, and then divide by 2, and you get negative 10.83. The 0 means round down again. Got my two answers. I did quadratic formula there. Here's one the students get, and they do the crazy long way. They expand it, then they factor it again. Look, it's already factored. That's factored form. 2 brackets. So how do you solve something when it's already in factored form? Just set it into 2 pieces. Either the x plus 2 equals 0, or the 2x minus 5 equals 0. So subtract 2 both sides here, and x is minus 2. Solved. Well, at least the first one. And the second one, first add 5 both sides, and you get 2x equals 5. And divide both sides by 2, and x equals 2.5. Look how quick that was. Make sure to recognize if it's in factored form, just solve it with 2 pieces. I'm over here now for question 5. I just tried to squish it all in onto one page. This says x squared equals 29, and I showed you in an earlier example, what's the opposite of square? A plus or minus square root. So I'm going to plus or minus square root both sides, and so I get x is 2 possibilities, plus or minus, and now I got to calculate what's the square root of 29. It's round to 2 decimal places, so 5.385. 5 means round up, so that's 5.39. So x is plus or minus 5.39. So 2 possibilities. X is 5.39, or x is negative 5.39. Whoa, almost forgot. I definitely rounded there. Don't forget. Oh, not on this line. I did my rounding on this line here. From here to here, there's no change. I don't put a rounding dot unless I rounded on that line. What line did I round on? From here to here, so put a rounding dot there. Here I just restated my answer in 2 pieces. No new rounding happened. No new rounding dot. So that was 1, 2, 3, 4, 5. Last question I snuck in over here. Just to remind you, a last thing to do is, before you think quadratic formula or factoring, think common factor first. What goes into 3p squared? That goes into negative 21p. That goes into 30? A 3. Put it out in front and divide each term. 3p squared divided by 3 gives p squared. Negative 21p divided by 3 is negative 7p. And 30 divided by 3 is 10. And now we can factor using BergMAN technique. I'm trying to multiply to positive 10 and add to negative 7. You can use your calculator to see what multiplies to 10 and guess and check till you get it. And I can see to multiply to 10 it's either 1 and 10, that won't work, or 2 and 5. And I just need to make the 2 and 5 multiply to 10, add to negative 7. The only way to do that would be with negative 2 and negative 5. So I get 3p minus 2 times p minus 5 equals 0, but we're not quite done. We factored, but we haven't solved until we separate it into two pieces. Either the p minus 2 equals 0, or the p minus 5 equals 0. How do we get our two answers now? Add 2 to both sides, and we get p equals 2. That's one answer. And add 5 to both sides, we get p equals 5. And we've done it. We've solved quadratics in many different formats. We used BergMAN technique in question 1 to solve. In question 2, we had vertex form, so we just rearranged to get x by itself to solve. In question 3, we used quadratic formula because it didn't factor. In question 4, it was already in factored form. We just used two pieces. In question 5, we just had to square root plus or minus both sides to solve. And in question 6, we used a combination of common factor first and then BergMAN technique.